This lesson is 3.4, Measures of Central Tendency. So this is a measure of a single variable statistic, and central tendency simply means the way that things generally have a center to them, right? So if I have a whole list of people's heights, for example, it'd be useful to know what the average height is, right? So maybe they're ranging in height from 5 feet tall to 6.5 feet tall. What's the average height? Well, there's different ways of measuring it. It's not necessarily just the very middle, as in halfway between 5 feet and 6.5 feet. It could be some sort of weighted average. It could be what's called the median. It could be the most common one, the one that comes up the most, which we call the mode. So we have these different ways of talking about what's the middle of a set of data, all right? So let's take a look at those three different ones I just referenced quickly. So the first one that we're going to look at is the mean. We often call that the average. To find the mean, we just add up all the numbers and divide by the number of numbers. So very straightforward. You're used to doing that, in fact. You've probably been doing this since elementary school. Here's an example. Well, actually, before I do the example, let me just highlight what we're going to do. To find the mean, nope, that's not a highlighter. Here's a highlighter. To find the mean, we're going to add up the numbers and divide by the number of numbers. Now an example. Jessie is buying a home that will require a mortgage. The bank wants to know her monthly salary. She works on commission, so she must calculate her average salary. Remember, commission, in case you didn't know, is where you get paid a percentage of what you sell. So maybe your commission is 10% of your sales, or maybe it's 5%, maybe it's 20%, depends on what you're selling. So she gets a commission, which means that she doesn't always get paid the same amount each month. What she gets is based on how much she's sold. Given her income for the first 6 months, what's her average salary? Well, so here are the 6 different monthly earnings that she got. So, since there's 6 months here, we're going to add these all up. Sometimes we use a variable like x with a line over top of it. I'll call that x bar as a short form way of writing mean. And again, mean is just the average. So that's a short form way of writing average. So we're just going to add up 3, 6, 7, 5 plus 4, 2, 5, 0, etc. And we're going to divide them all by 6 because it's the first 6 months of the year, or the last 6 months, let's say. So when we add those all up, divide it by 6, what we get is 3730.83, and that's dollars. So we know that her average salary is $3,730.83. 1 month, the lowest month, April, she only made less than $3,000. Her highest month, which was February, she made $4,250. So this is the middle between it. It's not exactly halfway between $4,250 and $2,985. It's when we add them all up and then divide by the number of numbers. So that's one measure of central tendency. Another one's called the median, and the median is defined as the middle entry in an ordered list. On report cards, you'll usually see a class median mark given. So it's not everyone, it's literally the one that's in the middle. So if there were, say, 9 people that I wanted to take the median height of, I would line them all up in a row, and if there's 9, the middle person would be the 5th one, right? Because there would be 4 people to the left of that person, there'd be 4 people to the right of that person, and that middle person would be my median. I could get the height of that person, and that would be my median. That works if you've got an odd number of people. You can, again, take that middle person or middle data piece and just make sure you got an equal number on either side. And that's what the first part A there is talking about. If there's an odd number of data points, take the middle one. If there's an even number, there is no one middle one. All right, say there were 10 people in a row now. Add one more person to the row somewhere where they belong. Well, the fifth person wouldn't be the middle one because there'd be 4 people to the left and right. Anyway, there'd be 4 people to one side of the fifth person and 5 people to the right side of that person, or to the other side of that person. For 6 people, if you try to take the 6th person in the line, well, the same problem occurs. So if there's an even number of people, there's no one person in the middle. So what you do is you take the average of the 2 middle numbers. And again, that gets us right down the middle. So we have to pay attention to whether we're dealing with an even number or an odd number of data, pieces of data, when we're doing the median. That matters. So find the median mark for each list of students' grades. Here's a list of grades. So they're not in order. The first thing that, oh, I'm sorry, I take it. No, they are not in order. Almost in order. There's a couple out of place, though. So we need to put things in order first. All right, so if we take these numbers, place them in order, we have 54, 62, 64, 72, 76, 89, and 93. Those are the numbers. And sometimes it's useful to cross them off as you go along, just to make sure that you've got all of them and that you don't double up on any of them. Anyway, they're in order, and we can see there's 1, 2, 3, 4, 5, 6, 7 pieces of data. So the middle one would be the 4th one. And the way I know that, again, is if I look at that where I've circled it, to the left of the 72, there's 3 numbers. To the right of the 72, there's 3 numbers. 72 is the middle one in the list. That's the median. If I were to do that again for this next number set, 56, 62, 63, 67, 84, and 98. Now we've got 6 pieces of data. So we don't have one number that's in the middle. What we have are 2 numbers that we can, if we take these 2 numbers, then we have an equal number of pieces of data to the left and an equal number of pieces of data to the right of these 2 numbers. We'll take the average of these 2. So the average of these 2 average equals the median. So what we'll do is we'll go 63 plus 67 divided by 2, and it's such an easy one that it's just going to be 65. We don't even need a calculator for that. So the median in this case is 65. Even though that's not actually a number in the data set, that's what the median would be, the average of the 2 middle numbers. So it's always 2 numbers we're taking the average of if we're doing the median of an even number of data points. The last one is the mode. It's the most frequent number in a data set. There can be no mode. There can be more than one mode. So find the mode of each set of numbers. Well, we want to find the number that turns up the most. So a quick scan through this. It's useful to put them in order. Usually what we're doing is we're trying to find all 3 of them anyway, so we'd have them in order from doing the median already. But since we're not, this is a fairly small number set, I can pretty quickly see that the 5 turns up twice, and there's no other number that turns up more than once. So the mode in this case would be 5. For the next set, we've got 25. It turns up twice, but so does 30. So here's a case where we have two modes. You can have more than one mode. As it said above, you can also have no modes. But in this case, the mode is 25 and 30. It's both of them. And this last one, if you take a look through it, you'll see that 79 turns up 3 times. 63 turns up twice. I don't know if any other numbers turn up more than once, but even though 63 turns up twice, the fact that 79 turns up 3 times makes it the mode. And there's only one mode in this case. It's the single highest one if there's only one. All right. When do I use the mean, median, or mode? Well, mean is most useful when data is grouped fairly closely together. That's an important one to consider. So as long as we don't have what's called an outlier, one number that's far away from the others, then we can use the mean. Median is more accurate than the mean, especially when there is an outlier. So again, an outlier, a number that's far away from the others. And I'm going to do an example in a second, so I'll talk about that a bit more. But the median isn't affected by outliers. Every number in a data set has equal weighting, whereas in the mean, the average, an outlier can have a big effect. Think about this example. Imagine I've got a class and everybody's getting about 80% in the class. You know, I've got 20 people in the class, 19 of them are getting 80s on average. But there's one person who hasn't come to class. They basically have not come since the beginning of the semester. They haven't handed anything in. They've got 0. So 19 people are getting 80s and one person's getting a 0. Obviously that 0 is going to bring down the mark. The problem is that 1 0 is so far away from all those other marks, it's going to bring it down more than it should. And so that 1 0 will have a disproportionately large effect. So that's the problem we're talking about with mean. So as long as there aren't outliers like that 0, then it's fine. But for a median, that doesn't even matter. That 0 is just one other number, and the median for that example I just made up would be 80. Mode is most useful when you need to know the most commonly occurring number. It is the only choice to use with categorical data, such as eye color. You can't have an average eye color. You're not going to blend all the eye colors together, for example. So for categorical data, you just want to know the mode. Maybe most people have brown eyes, and so on. The following are some test marks. In each case, identify whether the mean, median, or mode gives the best indicator of how the class is doing. So if we calculate each one of these things, if we were to put this first one in order, because we're going to need that for the median anyway, right? Then I'd have 5, 70, 71, 72, 75, 78, 78. All right, so now they're in order. So when they're in order, the median is very easy to see. So I see that there's 6 pieces of data, and 6. Oh, I forgot to write down that second 78. There we go. There's 7 pieces of data, and the middle one is the 72. So this is our median. If I was to take the average, if I add these all up, 5 plus 70 plus 71 and so on, and divide it by 7, what I get is a mean of 64.14. And the mode would be 78, because that one occurs twice, right? So we've got, take a look at that original data set. If we look at it in order, it's 5, 70, 71, 72, 75, 78, 78. Then we got these three measures of central tendency, 72, 64.14, and 78. Which do you think best represents the middle of this particular set of data? Which one is most representative? I would say the best representation is the median, because 6 out of the 7 numbers are between 70 and 78, and the median is 72, so that makes sense. The mean is way lower, it's down at 64, and that's been affected by that outlier, that outlier of 5. And the mode is kind of high, right? I wouldn't say that 78 is really a good representation of the middle of this data set. For the next one, we have, the numbers are already in order. We got a lot of repetition here, so it's pretty obvious that the mode is going to be 30 and 90. The median is going to be the average of the two middle numbers. So that's going to be 60. And the mean, if we add everything up and divide by 6, also turns out to be 60. So again, we've got these different representations of central tendency. Which one is the best? I would have to go with the mode in this case, because that really shows that there's two extremes. There's the 30, there's the 90. Doing both the median and the mean in this case give us this middle of 60, but what does that really mean? It doesn't let us see that there's those two extreme groups of data. All right, the last one. If I take a look at this, quickly check, and I don't see any mode. Oops, let's do it in blue. Mode, none. We can have no mode. There's also no outliers. Because there's no outliers, that means that the mean is okay. But of course, anytime the mean works, the median also works, so I would say either one is fine. But this is a good example of a time when the mean is fine. No outliers, the numbers are fairly closely grouped together, so there's no extreme cases affecting things. Last example. In a class survey, 10 students had blue eyes, 8 students had hazel eyes, 7 students had brown eyes, and 2 students had green eyes. Determine the best measure of central tendency. Okay? Well, this is categorical data. So we have to go with the mode. We talk about the 10 students who have blue eyes being the most common eye color in this case. So we can't have an average, we can't have a median in this case. It simply wouldn't make sense. Okay, here's one further example I just want to stick on here because I think it might help with homework a little bit. And I just want to talk a little bit about a weighted mean. So let's say that, let's do it in brackets there, 10 people got 60% on a test, okay? Two people got 70%. One got 100%. find the mean, median, and mode. Okay. Well, as far as the mode goes, that's easy. Again, if it's listed, they tell me a specific number, then the mode has to be 60%. There's a total of 13 people. 10 got 60, plus 2 got 70, plus 1 got 100. That adds up to 13 people. So I could list them all out, but I could even just mentally think, if I was to list them out, I'd write 60 10 times, I'd write the 70 twice, I'd write the 100 one time. And out of 13 people, the middle number is going to be the 7th one. Well, I'm still in the 60s, right? So yes, I can write them all out, but I can even just mentally visualize that if I were to write them all out, I would definitely still be writing 60s out by the time I got halfway through that list. So I know the median is 60%. The mean, though, again, remember I can represent that with a variable with a bar over it. I could do that as a weighted mean. So instead of writing out 60 plus 60 plus 60 10 times, I could do 10 times 60 plus 2 times 70 plus 100, or 1 times 100, but I don't need to write 1 time since it won't change things. And as I already said, there's 13 if we add them up. If I do 10 times 60, that's 600, plus 2 times 70 is 140, so we got 740, plus another 100 is 840. And if we do 840 divided by 13, I think what we get is 64.6%. So there's the mean, the median, the mode, and I think that might be helpful as you go forward. The homework is just below the note that you'll find on OneNote. Here it is. You can see there's a few questions and the answers, so you can check your work.